next term is isomorphic graph. Two graphs are said to be isomorphic if there is one-to-one correspondence between their vertices and their edges, such that incidences and adjacency are preserved. So, two given graph is called as isomorphic if they following the following condition. That is, first one is say both should contain the same number of vertices. Second, both should contain same number of edges, and third is both having same number of vertices with a given degree. So if these three conditions are satisfied, then this two given graph is called as an isomorphic graph. Let's see the example. So these are the two given graphs. So we will check one by one. First condition is that both should have the same number of vertices. So you can see that graph, suppose this is the graph G1, this is the graph G2. It contains 8 number of vertices, it is also contain the 8 number of vertices. So first condition is matching. Second condition is it should contain the same number of edges. So if you see in the first graph, number of edges are 12 by counting. And if you see the graph number means graph G2, in graph G2 also there are 12 number of edges. So second condition is also satisfying. And third condition to check the isomorphism is that adjacency should be preserved. Means adjacency means what? If the vertex A is adjacent with three vertices, that is G, H and I, so degree of all this should be the same. So if you see A degree is 3, G degree is 3, H degree is 3 and I degree is also 3 in this case. So same so in the graph G2 these vertices should be adjacent vertices, but you can see that vertex 1 is adjacent with the A and its adjacent vertices are 4, 5 and 2. And if you check the degree of these vertices 4, 5 and 2, it is also 3 respectively. So these are adjacent, means adjacency is preserved as per the rule. So all these three conditions are satisfying, that is both graph having same number of vertices. Second condition, both graph having same number of edges. And third condition is that adjacency should be preserved, that is same number of vertices with a given degree. Then this is called as a isomorphic graph. So in this case FA is adjacent to 1, FB is 6, FC is with 8, FDE is with 3 and FG is with 5. You can see that. So adjacent vertices is shown by the same color in these two graphs. So these are the adjacent, as all the three conditions are satisfying, it is a isomorphic graph. Now next problem is that find whether K6 and K33 are the isomorphic or not. Now we know that this is the notation of complete graph. This is the complete graph with the 6 vertices, and K33 is nothing but the K33 is a bipartite graph with two vertex set. One vertex set is of 3 number of vertices, and second is also with the 3 number of vertices. So in this case we can see that complete graph with the 6 vertices. In this case each and every vertex degree will be n-1, that is nothing but 5. So degree of each vertex will be the 5. But in case of K33 we can complete bipartite graph. If it is complete bipartite graph, in that case degree of each vertex will be 3. So first condition is satisfying, that is 6 number of vertices here also 6 number of vertices. Second condition, number of edges in this case will be total number of edges. We are having a formula that is n into n minus 1 upon 2. So in this case 6 into 5 divided by 2, so 30 divided by 2, that is nothing but 15 number of edges will be contained in this K6. So here 9 number of edges will be contained if it is complete bipartite graph, so 3 into 3, and second condition is not satisfying. That's why we can say that it is not isomorphic graph. If you see next term, that is a subgraph. So there are two given graphs. So graph B, if you see, is a subgraph of the graph A. So what do you mean by the subgraph? So if G, V, comma E be any graph, then a graph G dash which contains V dash comma E dash, where V dash is nothing but set of vertices and E dash is nothing but set of edges, is said to be a subgraph of G if E is proper subset of E and V is a subset of E and V dash is a subset of V. Here E is nothing but set of total number of vertices, E is a set of total number of edges from the original graph, and V is the total number of vertices from graph A. So you can see that this vertex set is a subset of vertex set of graph A, and edge set is also the subset of edge set of this graph A. Therefore this B graph is a subgraph of graph A. Now next is complement of a subgraph. So complement of subgraph is nothing but suppose G dash which contain V dash comma E dash with respect to the graph G is another G double dash, means for complement of the graph we given that notation G double dash which contain vertex set V double dash and edge set E double dash, such that E double dash is equal to E minus E dash and V double dash contains V minus V dash. So it contains only those vertices with which the edges in E dash are incident. So edge set will contain, edge set of the complement of subgraph will contain edges E minus E dash, and vertex set will contains only those vertices with which the edges in the E double dash are incident. So if these are the graph taken up previous graph only, so graph A and B is a subgraph of graph A. So complement of graph A B with respect to the graph A is nothing but this one. You can see that edge set is containing E minus E dash. E minus E dash means the edges which is contained in the original graph but which is not in the subgraph. So these two edges are removed and all other edges are taken into the complement of this subgraph. So these are nothing but AD, BC, BD and CD. These edges are taken and vertex set of complement of subgraph contain all the vertices with which the edges in E double dash are incident. So these edges are incident on A, B, C, D. That's why these vertices will be taken as a V double dash set, in the V double dash set. So this is complement of the given subgraph. Now next term is spanning subgraph. Spanning subgraph means a subgraph which contains all the vertex of the G. That is called as a spanning subgraph. Means suppose this is the original graph, that is G9. So spanning subgraph of G9 will contain all the vertices from the original graph, but it may not be contain all the edges from the given graph. So edges may be missing but vertices should be present, then it is called as a spanning subgraph of given graph. So if you see here, this first example, that is 1, 2, 4, 5, 3, it contains all the vertices from the given graph, that is G9, and edge is missing, so it is a subgraph of G9, and it is called as a spanning subgraph because it contains all the vertices of the given graph. But if you see the second subgraph, it is a subgraph but it not contain all the vertices from the original graph, that is G9, so it is called as a, it's not called as a spanning subgraph, but it is a subgraph. Next subgraph is edge disjoint subgraph. So subgraph is called as a edge disjoint subgraph if no common edge in two subgraphs. If no common edge in two subgraphs. So if you see the example here, H1, H2 and H3, these are the subgraph. So here DC, AD, BC, if you see, there is no any common edge in this subgraph. That's why these subgraphs are called as the edge disjoint subgraph. Now, vertex disjoint subgraph. Vertex disjoint subgraph is nothing but subgraph in which there is no common vertex in two subgraphs. Then it is called as a vertex disjoint subgraph. So if there is no common vertex, so in this case these are the vertex disjoint subgraph. Then this is also vertex disjoint subgraph. But if you take this, it is not a H2 and H3, it is not a vertex disjoint subgraph as there is a common edge here. Sorry, common vertex is there. Next term is factor of graph. K factor of a graph is defined to be spanning subgraph of the graph with the degree of each of its vertex being k. So if you see this graph, this is the spanning subgraph and degree of each vertex is 2, so it is called as a two-factor graph. It is the spanning subgraph because it contains all the vertices from the given graph and these two edges are missing, so it is subgraph of this graph, and it is called as a k factor because degree of each vertex 2 factor, k value is 2 here, so it is called two factor graph because degree of each vertex is 2. Now next term is planar graph. Term, or we can say type of graph, planar graph. A graph G is said to be a planar graph if it can be drawn on a plane without intersecting the edges except at the common vertices. So no edge is intersecting with each other. In that case, that particular graph is called as a planar graph. You can see the example here. These are the graph which is drawn on the plane and there is no any edge which is intersecting with each other. Intersecting means this is the edge and suppose there is one more vertex here. So, and if I draw like this, the edges which is not crossing with each other means in that case it is called as a, if edges are crossing with each other, then it is called as a intersecting with each other, and it will not be planar graph in that case. So here these two are the example of planar graph. There is Euler formula which is used for finding the number of vertices, edges and regions in the planar graph. So for any connected planar graph, there is a formula V minus E plus R is equal to 2. So V is, in this case, V is number of vertices, E is number of edges and R is number of regions. So we will see what is meant by